You may have seen balloons stuck to the wall or ceiling, but you may not know why and how does it remain there without any taping or other things. Yes, this is what we will explore today and understand it. So let's begin. If you have seen my earlier videos on structure of atoms, you may know all its names and properties. So let's quickly revise the structure. An atom is made from subatomic particles which are electrons, neutrons and protons. The nucleus consists of protons and neutrons and electrons which orbit them in a shell. This all I have already told you in my last video. So what's added to it? Yes, the formulas which is used to find the maximum number of electrons a shell can hold with the formula 2n square. For example, if you need to find how much is the maximum capacity of electrons second shell can hold, you place 2 instead of n and then solve further. What we get is 8. So this tells us that the second shell can hold maximum of 8 electrons. And you can use this formula to find any shell's maximum capacity of electrons. Now, you may think, why am I telling you about atoms if it has no relation with the balloon on the ceiling? But you are wrong. It does have a relation with the atoms. So, how is it electrostatics? Let's understand. Balloons have a property to gain electrons, and they also have the potential to keep the gained electrons stable, and the balloon becomes charged with static electricity, and this is nothing but electrostatics. If you understood, it's nice, but if you didn't, let me explain it in more depth. When a material is rubbed on a cloth such as wool, it gains electrons, which means it has more of negative charges than positive charges, and so it is said to be negatively charged, and same for balloons. So rub the balloon on a woolen cloth if you have and try touching it to the wall or ceiling. It will stay there for some time. So what happens is, as the balloon has negative charges, when you take it near the wall, the electrons of the wall repel and turn to another side, and the protons face this side. Now the protons attract the electrons in the balloon, and this is how the balloon stays in the wall.